So lack of bench space here makes this a little bit hard to shoot. But this is the Model 1 that we removed the Sprinter card from. Disassembled it, reassembled it, and got it back in the machine. And this will be the first power-up test, just to see if the machine has any life or if I've broken something. That's an excellent sign. So I must have got the keyboard cables on correctly for my little kludge down here. There should be a 16K machine. And it is. So off camera here, I'm going to write a little basic program to test out the speed board, and then we'll come back and we'll take a look to see if it works. So this is our little program to test out the Sprinter 1L. We'll put the message slow. We will set the system back to the normal clock speed. We'll go down to a print routine that'll just print the characters from 32 to 191. It'll print a return to get to the next line and return. It'll then print out the string fast. It'll output 254,5, and the 5 says run at double the clock speed. It'll do the print routine again and then just sit here in a loop. So let me go ahead and run this, and we should see it print the string out slow, then print it out fast, and toggle back and forth. So there's slow, there's fast, there's slow. So the board does appear to be working, which is really nice. So we didn't damage it, apparently, which is nice. The system, at least at this level of testing, is stable. So that's pretty sweet. So I'm going to try to push the machine even faster than 100%, and we'll see what we get. So looking at the little chart here, it gives us various speeds. I'm using out 254.0 for the normal speed mode. Out 254.5 gives us plus 100%. I'm going to try an out 254.12, which will give us a 200%. I expect the system to crash when we get there, but we'll find out. I honestly don't remember from before. We've got the same code here. We went slow, it's off the screen, fast, and then we're going to do a fastest. I'll put the 12, go to 100, the subroutine, and then loop. So I have no clue if this will work or crash. I suspect it'll crash, but let's find out. So there's slow, double speed, triple speed, slow, double speed, triple speed. I can't tell if there's a difference between the double speed and the triple speed. I may have to modify the subroutine. I do believe the fastest is faster. Well, I'm going to modify this to see if I can make it a little more obvious. Well, I think we're down to what's going to be the final program. This will make 3 passes, filling the screen at the normal clock at 200% and 300%, and it'll display the CPU clock on the top of the screen. Get this microphone cable out of the way, and let's go ahead and run this. And we see the 1.77 megahertz. This is the normal clock speed for the Model 1. This is at 3.55 megahertz or double speed, and 5.32 triple speed. And I believe the triple speed is faster than the double speed. It's kind of hard to say at this point. Yeah, it seems faster. It doesn't seem 3 times as fast to me, but that's really kind of hard to say. Let me actually break out here. This through 100, and let's just look at the code. So for the fastest, we're doing an out 254.12, which does say 5.32 megahertz in the little manual here. That's plus 200%. So according to the code, we're good. Whether in reality it's making a difference at the triple speed, I don't know. See the camera seeking here for brightness control. So this is at 3 seconds, 4 seconds, 2, 3. Try that again. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. 1, 2, 3, 1, 2, 3. Not sure if the high speed mode's actually doing anything or not. Anyhow, Sprinter card still seems to work. I don't know whether that high speed mode actually worked previously or not. I guess one way to find out here would be to get a hold of the clock coming to the Z80 and just see what speed it's running at. I suspect there's weight states being injected here in the highest speed mode, though I don't know that. It is a Z80B processor in the machine, so it is capable of, I think, more than 4 megahertz clock. Anyhow, I'm sorry about the focus seeking and the brightness seeking. I will, that might actually do a little better. I've got it looking directly at the screen here for focus and intensity, and that does seem more stable, so I'll let you have a few more passes here with a little bit more solid video. And again, I'm just watching it on the actually the monitor here on the camera, trying to get a sense for speed. Yeah, the high speed mode does seem quicker. I suspect we're getting weight states installed. Maybe I'll write a different program and do some math in all 3 modes and see what that gets. That might actually be a good indication. So I'll go write that code next and we'll come back. Okay, so modified the subroutine basically to count from 0 to 10, print out the loop we're in to the screen so we can see loop Y 0 to 10, loop Z 1 to 10, and then just do some floating point math here, X times Y divided by Z, loop through and return. And what we hopefully will get a better sense of here is speed. We'll find out. So obviously that's pretty slow. That's at the normal clock rate. This should be twice as quick, essentially. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 5.32 megahertz does seem faster. Let me see if I can kind of see the timer on the clock here, or on the camera. See if I can get a sense of just how long it's going to take. 9. So there's 21 seconds. So it was 9 seconds, just almost 10. And this is going to be in the range of 8 seconds, so it's a little bit quicker. So I'm guessing weight states are getting injected onto the bus or onto the CPU. It is faster, but obviously not a full 300%. Internally in the processor, it's running quicker. Anyhow, I think with this, I will call this good enough. And we'll wrap up this video and we'll talk soon.